Okay guys, this lesson's called the triangle side splitter theorem. So what it says that a line segment splits two sides of a triangle proportionally if and only if it is parallel to the third side. So what does that mean, right? So we're going to kind of look at it in terms of this example. And we've actually talked about this before, so hopefully this kind of makes sense to you guys. So they're giving me that if these two segments are parallel to each other, then the following has to be true. And we just kind of saw this happening in proofs, but like, why would this mean that this is true? Well, we know that when we put these sides in proportion, so like this side over this side to this side over this side, that means the triangles have to be similar. So let's try to get the sides to be similar first. So if these lines are parallel to each other, that means that we end up having corresponding angles being congruent. This angle and this angle there, I'm going to number them 1 and 2, would be congruent. And right, because like think of corresponding angles, right, with parallel lines cut by a transversal. That's what I'm seeing here. Then I would have angle 3 being congruent to angle 4 in the same way. So therefore, because angle 1 and 2 are congruent, angle 3 and 4 are congruent, because when parallel lines are cut by a transversal, corresponding angles are congruent. This small triangle BDE is actually similar to the big triangle BAC by angle. And therefore, if two triangles are similar, we know that corresponding sides are going to end up being in proportion. Okay, so this is like what you want to copy for our reasoning down below. Okay, so if angle 1 is congruent to angle 2 and 3 is congruent to 4, because when two parallel lines are cut by a transversal, corresponding angles are congruent. Therefore, triangle BDE is similar to triangle BAC by angle. Therefore, if two triangles are similar, we know that corresponding sides are in proportion. Therefore, the small side right on this triangle will map onto the small side of the big one, and this one will map onto that one. And that's kind of like the basis of this whole lesson that we're about to do, is the fact that if they tell you guys that you have the two sides being parallel, then it actually gives you similar triangles. And when we have similar triangles, we can do proportions to solve for missing side lengths. So this is our approach to these kind of problems, right? What you want to do is draw the triangles separately. So you guys see how they gave you that DE is parallel to AC? Right away, when they give you that those are parallel and they're overlapping triangles, I know that the triangles are similar. So everything on this page, they're all similar to each other. So this is the strategy you guys are going to do. You're going to draw the two triangles separately. So you have this small one, BDE. Okay, so all I did was take this one, okay, and I drew it off to the right. Okay, BD they told you is 6, BE they told you was X. Okay, then you're going to draw the big one that it's laying on, right? So the big one is ABC, ABC. Okay, so that's this one. Okay, and I want you to draw that here and do your best. It doesn't have to look like amazing, but this is like the general idea that I'm talking about. And you can highlight if you want like I am, that's fine. So from A to B, that's just an 8. And then from B to C, that's 16. So now that it looks like this, and I just separated, like I just pretty much yanked the pink one off of the orange one, it makes it so much easier for me to solve. Because now, since I know they're similar, I can just set it up, and they set up actually right above each other. So like 6 over 8 is going to equal X over 16. And then from there, I can solve that super easily by cross multiplying. And then I would get 96 divided by 8, and I get 12. Okay, I'm going to do that same process for everything on this page, and you'll see that this method of doing it works every single time, of just like sketching the triangle separately. So for the next one, okay, I'm going to draw the little one. That's BDE. And then we got the big one, which is ABC. They gave me BD is 2, BE is X, right? And then they gave me, so hold on, let me just highlight again. So this is the small one, right? Now the big one, remember, this is like the whole side, like it's the whole thing. So little different this time. That's why every example is going to have a different piece, but this whole side, this whole thing from A to B is just 8 plus 2 added together, or 10. So this whole side right there is actually 10. And then this whole side, how I denote it, if you have X and 12, you just add them together to get X plus 12. So that's what this side is just an X plus 12. Okay, and now that you have it all set up, 2 is going to map onto 10, so 2 over 10 will equal X over X plus 12. Now, once you have that, you guys are just going to cross multiply this. Any couple, though, keep in parentheses for that first line, right? Because you're going to have to end up distributing that 2. So 2 times X plus 12 will equal 10X, right? 10 times X, and then distribute that. You get 2X plus 24. Will equal 10X, and then subtract 2X on both sides. 24 is 8X, divide by 8, and you get X is 3. Okay, and then for 3 on this page, we'll do it again. So we got D, B, E as the small one, and then we got ABC again as the big one. Okay, so let's see, we got this. Okay, so, and some of you, once you get the hang of this, I mean, obviously you might not need color if you get it. Some people just do better with color. But I'm just pulling them away from each other. Okay, now this side of the pink one, the BD, if the whole thing's 15 and this part of it's 6, that means that that side has to be 9. And then BE, they already have labeled as X. So that's the sides of the pink one. The side AB is already marked as 15. The side of BC then is going to be X plus 8, or 8 plus X. It really doesn't matter what order you go with that. So there you go. So now I'm just going to do 9 over 15. And you algebra people are going to like this because it's all like algebra skills. So 9 over 15 will equal X over X plus 8. Cross multiply again. Keep that couple in parentheses, at least for the first line. Distribute. Okay, subtract 9X. 5 by 6, and you get 12 is X. Okay, turn the page. Okay. So just some more examples. I mean, it's the same thing, but there is a shortcut, right? So there's a shortcut that you're allowed to do. And I just want to point out the method I just showed you will work 110% of the time. Okay, always. But a shortcut version, and it does not work if they give you the bottom bases, which we're going to be doing on the next page, okay? But a shortcut that you're allowed to do is that this side broken up to this side will be equal to this over this. And again, it's called the side splitter theorem for a reason. It will only work on the sides. If they put the numbers on the bases, you have to draw them separate. Okay, drawing them separate will 110% of the time always give you the right answer. But like this is an example of using the side splitter theorem. 6 over 3 will equal 10 over x. Okay, and then cross multiplying that, 6x would equal 30 divided by 6, and you get x is 5. So that was a lot faster than having to like take the time to draw them separate. And I could do that on this one as well, because BE I can find by doing 56 minus 21, which is actually 35. And then now, since it's on the sides being split by DE, I could do 28 over x will equal 35 over 21. And then cross multiplying that, I get 35x is 588 when I multiply 28 by 21. Divide by 35, and I get x is 16.8. Okay, so then for number 3. So for number 3, it says these lines are parallel. DB is 6, AE is 8, and then they said EC is 3 times AD. Find AD. Well, EC depends on what AD is, so I'm going to call AD x, and if EC is 3 times it, that would be like 3x. So since it's the side splitter, I could just do 6 or 8 x over 6 would equal 8 over 3x. And just like cross multiply that and solve that. So x times 3x would be 3x squared. 6 times 8 is 48. Divide both sides by 3. X squared is 16. And then I would square root both sides and I get 4. And this question was asking you what AD is. So AD is x, what we called x. So AD is just going to give you 4. Okay. Now, number 1 on the exercises is an example of where you cannot use the side splitter theorem. Okay, can't do it. And it's because now they're not giving you CN and NB. So this is super important. The only way that you can solve this question is by drawing the triangle separately. Okay, so they're asking you to find MN. So I'm going to draw the small one. So CMN. This is X, this is 6. And then I got the big one, which is CAB. And CA is 8, AB is 12. Okay, so I'm really doing 6 over 8 is x over 12. I'm not doing 6 over 2 is x over 12. You'll see if you do that, it'll give you like something insane there. It ends up giving you like 36, which wouldn't make any sense. And that's because the side splitter only works for the side split. It does not work for the bases of the picture. So this one I would do 6 over 8 is x over 12. And then I would cross multiply that. So 8x is 72, right? 6 times 12 is 72. Divide by 8, and I get x is 9. And that's what we called MN. So that would be my answer. Okay. So for this one, they gave me DB is 6, AD is 2, DE is 9. Find AC. So again, they are not giving me the split side. They're not giving me this side. So I can't just do 6 over 2 is 9 over x. I mean, I'll show you real quick. It ends up not giving you anything good. Like 6 over 2 equaling 9 over x would be 18 is equal to 6x. X is 3. That doesn't make sense for x to be 3. It's bigger than 9. Like this side's bigger than 9. That's why it does not work. So drawing separate will always work, whether it's side splitter or not. So that's why this is my method of choice. I still want to show you guys the shortcut, you know, to save you time. But like this one, you have to draw separately. So we have B, D, E, and this is a 6 and a 9. And then this is A, B, C. AB is 6 plus 2 or 8. And then this is the side we're looking for. So instead, what we're setting up is 6 over 8, not 6 over 2. You see the difference? So 6 over 8 has to be 9 over x. So 6x is 72. Divide by 6 and you get 12. And 12 makes a lot more sense than 3. Okay, so hopefully you guys watch all of this and kind of stick to this method. When I do it, I always think of this every time, and then it works 100% of the time. Okay, so then 2 last questions. A vertical pole 15 feet high casts a shadow 12 feet long. Okay, so what that looks like is we have a pole 15 feet and it's casting a shadow of 12. So look kind of like that. At the same time, nearby, a tree casts a shadow that's 40 feet long. What side of the tree? Well, if it's at the same time, just kind of think about them like the tree and the pole standing next to each other. If the tree shadow is like 40, that means the tree obviously has to be a lot significantly bigger than the pole, right? It's going to be kind of like an image like this. They're asking you guys to find the height of the tree, or like how high the tree would then have been. So if you think about the triangle separately, it's going to be this small side over this side. So the 12 over 40 will equal the 15 over the x. And then cross multiply, 12x would equal 600, right? 40 times 15. 600 divided by 12, and you get x is 50. Okay, and then the last one, in the diagram pictured, a large flagpole stands outside of an office building. Josh realizes that when he looks up from the ground 60 meters away from the flagpole, that the top of the flagpole and the top of the building line up. If the flagpole is 35 meters tall and Josh is 170 meters from the building, how tall is the building to the nearest 10th? Okay, so I don't know how well you can like read these numbers, but they're giving you that that's 60, this is 35, this whole side length is like 170, and then they're asking you for the height of the building. So again, it's just like similar triangles. If you need to draw them separately, do it. But like you have this small triangle with the 60 and the 35, and then you got this big one where this whole side is 170 and this side is x. So you just have to put the sides over each other then. 60 over 170 is going to equal that 35 over x. And then I'm just going to cross multiply that. So 60x is 170 times 35 is 5,950. You could do that right in your calculator. Divide by 60. And you get to the nearest 10th, approximately 99.2 meters would be your final answer. Okay, guys, good luck on the homework.